Dude, welcome to California, the land of blonde, tanned and toned, but more importantly known as the land of fascinating geologic landscapes. Throughout this video we will use the San Andreas fault line in Southern California to explain the magic of favourable orientation. But first, let's get some facts straight. What is a fault? Yeah, dude. Faults are totally not our fault. A fault is a fracture in the Earth's surface, normally due to an increase in pressure which has caused the crust to give way in a sudden motion, aka an earthquake. Shaka bruh. When a fault moves, it is considered to be active, and these active faults have an opportunity to move multiple times in a process called reactivation. This is where a fault will keep rupturing in order to reduce stress. What is fault reactivation? Whoa! That came out of nowhere! Reactivation is where a fault will continue to rupture to release tectonic stress. Now over to Charlie for some more facts.
Cheers, Amanda. This stress can be divided into three main components. These are sigma 1, 2, and 3. Sigma 1 being the greatest stress, and sigma 3 being the weakest. These stresses all come together to create the normal stress. As you can see, a fault's motion depends on which direction the stresses are facing, as shown in the normal and reverse fault. A way of representing these stresses is the Moore circle. But not that kind of Moore circle. Now that is more like it. The Moore diagram is a tool used in order to plot a stress circle, which is a series of points showing the relationship between the shear and the normal stress. The model also shows a failure envelope, which is a portrayal of when the fault will fail/rupture. Notice the angle, 2 alpha, between the normal stress and the point on the circle. This is the angle multiplied by 2 between the greatest stress, sigma 1, and the fault line. Pay attention to this because it becomes very important later. So, what is the favourable orientation of a fault? Well, a fault is considered to be favourably orientated when it is able to reactivate, and unfavourable when it cannot. Well, this links back to our handy-dandy Moore diagram, and the angle I stressed, wink wink, about earlier. In order to reactivate, the alpha angle point needs to come into contact with the failure envelope. So what influences fault reactivation? Reactivation, my geologic gurus, is only possible if the original angle between the fault and sigma 1 is less than or equal to 60. An angle of less than 30 is considered to be optimally favourable. An angle of 30 to 60, just favourable, where at 60 it equals frictional lockup. And an angle greater than 60 is unfavourable. An angle greater than 60 will just never reach the failure envelope, no matter how much the overburden is increased. In addition to favourable orientation, there is also material strength, as different structures will have different strengths, meaning they can fail earlier or later than other materials around them. Even if a fault is unfavourably orientated, it can still reactivate if hydrostatic pressure is introduced. Now that we know what the favourable orientation of a fault is, we will have Amelia take you through the strange example of the San Andreas fault.
The San Andreas fault is a non-favourable fault. That's a fault with an angle of over 60 degrees that is still reactivating. The San Andreas is a strike-slip fault that extends through California for over 1,200 kilometres. There are 3 sections to the fault that are of importance here: the northern, the southern, and a shifty, wink wink, section in the middle. So why is the San Andreas considered non-favourable? Well, both the northern and the southern parts of the fault are in frictional lockup. This is the creeping section. This is where the fault is moving. It varies, but the sides of the fault are moving past each other at a rate of between 0 and 20 millimeters per year. You would expect this area to be favourable, to have an angle of say 30 degrees. That would be typical of a reactivating fault. But this section has a sigma 1 orientation of between 80 and 90 degrees. This makes it completely unfavourable. As shown by this Moore diagram, the alpha angle point doesn't hit the failure envelope. Poor fluid pressure relieves stress, and it could explain why the San Andreas is moving, but we don't know enough to say for sure. Now that our video has come full circle, we hope you've learned more about favourably orientated faults.